And welcome to the Daily Space Weather. We've got a huge sunspot just risen over the southeastern limb. We'll cover it. And lots more here at the Smash News Network. Least busted name of news. Just bringing you the most detailed daily space weather and comprehensive solar imagery you'll find in the known universe. This is a 24-hour video from SDO featuring the continuum as well as 171 angstroms ionized iron. Here's just the continuum. And you can see that large rising sunspot there, a little bit larger than planet Earth. We'll zoom out briefly here to show you some more views. Huge sunspot region there setting in the northwest as well. We'll also take you for a brief look here at what's going on. That is yesterday plus today. A little bit of sunspot degradation in the southern hemisphere, a little bit of modest growth in the northern hemisphere, and some migration happening. And again, two likely new named sunspot groups there in the southeast. Here's a brief look at the SDO magnetogram. And it's a fine time to be doing space weather, but let's briefly pause and take a look at what's going on planet Earth. There's been a series of earthquakes, lots of them, underneath Fagradalsfjall in Iceland. So the possibility of another eruptive episode happening there, it's some magma dike intrusion. Also, Nicaraguan volcano erupting. We'll cover that as well. San Cristobal. Here is your volcano rundown. And of course, we do this daily because of popular demand. Here's what's erupting. Again, Fagradalsfjall may be fixing to erupt again after over 2,000 earthquakes have been detected, consistent with the sequences in February, March, and December of 2021 and 2022. July and August of 2022, that is. Vertically propagating dike magma injections. Kluchavskoye also erupting there, producing some Strombolian activity. Mount Mayan in the Philippines continues to produce a 10,000-foot ash plume, flight level 100, flight level 250 over central Mexico from Popocatépetl. It's a 25,000-foot ash plume as the central Mexican volcano explodes. No emissions from Fuego, but San Cristobal featuring violent activity there. A powerful eruption culminated in dilute pumice and ash flows caused by partial eruption plume collapse due to its higher density than the surrounding air. Pyroclastic flows also occurring there at San Cristobal. Revenador, no volcanic ash emissions from Revenador, none in the country of Ecuador at all. Sabancaya, though, still exploding, flight level 240 over the Peruvian explosive volcano. Ubanas in Peru also exploding, flight level 180. And Pitan de la Fornez continuing to produce some more real estate there with an effusive eruption. Please do not pole vault the caldera. Here's what's going on in terms of seismic activity. We just showed you volcanic activity. All right. Learning to speak the English language once again today. That's the past 90 days of earthquake activity. And it's been pretty quiet. Not a lot of quakes and no big quakes. Although you can see some at the 4.5 magnitude there happening at Iceland. So, high possibility there of another eruption from Fagradalsfjall. Exciting stuff at Iceland. First on our list is the 5.8 at Chile. That was at 0 dark 31 this morning on July 6th. It was at 131 kilometers estimated depth, that 5.8 magnitude quake at Chile. Then 50 minutes later, a 5.2 strikes the central Indian Ocean there, near the African Indian plate boundaries. And most recent quake on the list here, just coming in, a 5.9 at the Bellini Islands there in between the Australian and Antarctican plate boundaries. On the Australian plate boundary side of that, 5.9 struck at 10:31 Universal Time this morning. And let's get back to space. Yeah, space. It's where it's at. And there are a lot of filaments on the Earth-facing portion of the solar disk, as you can see in this 24-hour SDO video, featuring ionized helium at 304 angstroms and ionized iron 193 angstroms from the AIA instrument. Alex Lifeson filament remains intact right here. The Bella Fleck filament remains intact over here, last I checked. We'll show you an update on that later in the video as well. Let's get through some more space stats here. The 10.7 centimeter radio flux is currently at 154 solar flux units. That radio signal comes out of the upper chromosphere and lower corona, a very thin portion of the sun's atmosphere, and it is consistent with sunspot number in terms of direct proportionality. In other words, lots of sunspots means high radio flux, low sunspots means low radio flux, and check out the upward trend happening here in the past 3 months. Higher highs and higher lows on both the sunspot number and the radio flux. Now we've got a CME, a coronal mass ejection, that is, folks, and it is headed this way. We are expecting it to arrive tomorrow. So sometime around or after midday tomorrow, expecting that CME impact. And it looks like NOAA actually agrees here. We could see a little bit of a higher geomagnetic storm level than is forecasted there from NOAA. I would be surprised to see anything higher than a 6.33. NOAA expecting only about a KP5 there, or a 4.67 for tomorrow's coronal mass ejection impact. Keep in mind there may be a co-interaction happening with the coronal hole high-speed stream as well. We already do see some coronal hole high-speed stream material showing up. We'll get to it here in a minute. First, we'll show the last 4 hours of Earth's magnetic moment from space. That is our geospace magnetosphere movie depicting magnetohydrodynamic pressure, again for the past 4 hours, and we have had a little bit of an uptick here in the past 18 hours in the solar wind parameters. Here's Earth's magnetic moment from the ground for the past 4 hours. This depicts magnetic flux density at the surface level. It'll show you the most likely places to see the aurora. Also, pipeline, railway, and power grid induction are likely in those reddest areas. It depicts delta B, changes to Earth's B field in nanotesla. KP index currently at 3. KP3 is the global average of geomagnetism. And next it's time for the real-time solar wind. So there's your real-time solar wind. Again, we have seen an uptick here since yesterday. It looks like a weak coronal hole high-speed stream as forecast. There you can see the density making up to it about just under 20 protons per cubic centimeter, then dropping down and the solar wind speed coming up. Also a consistently warmer signal there for the solar wind temperature. The plasma temperature is that green bar at the bottom. We just have had a recent switch over from the ACE to the Discover. Current conditions are solar wind density about 13 protons per cubic centimeter, solar wind speed 468 kilometers per second. There are our GOES magnetometers. Seeing some fairly smooth readings there despite that weak coronal hole high-speed stream impact. And let's take a look at some more important stuff. Here comes the top view ecliptic plane field plot. And this has massive predictive value. So our regular viewers may be familiar with this one, the top view ecliptic plane field plot. The data comes from 51 ground-based magnetometers and the magnetometers on stereo A and stereo B. It depicts the polarity of the solar plasma there. It is polar in that one or the other north or south pole orients that plasma. And at the moment, Earth is in a North Pole current sheet, and Earth might stay in a North Pole current sheet. By the time we get to tomorrow's video, there may be a little bit of a stalling of that sector boundary crossing, although it is possible to move into the South Pole current sheet. It does tell us something about the sunspot that rose in the southeast and the likelihood of a sunspot rising in the northeast and so forth. I won't get into it super in depth. That's the past 4 days. Here's the latest image again. There is a sector boundary crossing coming. Earth is about to move from the north to the South Pole current sheet. and it might not be as early as tomorrow's video. Here's our line of sight plot. You can see the sun's B field depicted here in blue, north and south, solar polar fields in green and red respectively, and the solar magnetogram in grayscale. Next is coronal holes. And there's our coronal hole line of sight plot. We have some south pole coronal holes rotating in here, just on the other side of that sector boundary crossing. So, and this often happens, folks, where the sector boundary crossing is kind of like this. And that is sort of what's happening at the moment. These magnetic fields are not as orderly as you may expect them from simple models. So let's take a look at coronal holes here in our SDO 211 angstroms wavelength. And again, the weak coronal hole high-speed stream that we're getting showed up a little bit early. It's from these systems right here. So that could continue on for a couple of days. It could be like a sputtering coronal hole high-speed stream. I don't think it'll affect the CME very much. I think the CME will produce a significant signal. Again, we could see as high as a KP 6.33 in my opinion, but we'll have to just wait to see what happens. It all does depend on a lot of factors, not just the density and speed, but also the magnetic field intensities. So let's move to sunspots next. There's your sunspot situation. And okay, they've already named 3362, so we'll have one new named sunspot group today. We may have some groups losing their names in the southern hemisphere especially. The most likely places to see large flares would be from 3361 and from 3359. So those are the magnetically complex sunspot groups capable of producing large flares. Flare risk has gone down a little bit, especially with the setting of that huge group that produced an X-class flare in the northwestern hemisphere. And let's take a look at sunspots in some splentacular detail. Here we've got the ever popular SDO magnetogram plus the 171 angstroms wavelength. So that's totally sweet. Really shows you where the sources of those magnetic fields are located. I mean, keep in mind the coronal holes of the corona have different magnetic fields than the photosphere, and you know, the 171 angstroms shows you the lower corona. So you're looking at the magnetic fields of the photosphere and the lower corona. That's the gold portion. And let's get rid of both of those and show the SDO continuum. Here's the full disk view, zoomed into the equator. And next we'll do solar flares and energetic particles. As far as the proton flux goes, no spikes. It has been nada, zilch, zero, zip, nothing, null when it comes to the GOES proton flux. There you go, no spikes. And we did have some significant flaring here. The flare profile still is significant. We've still got a C-class background level of X-ray flux. And we've recently had an M-class flare. That was an M1 at about 1050 this morning. There was also an M1 around 1900 yesterday evening. And let's cut back to our fantastic 24-hour SDO videos there. There's 131 angstroms. Here we've added 94 angstroms. Now it's a composite 131 plus 94 angstroms. And I think that most recent M-class flare came from that group in the northwest. So a prime example of how sunspots can produce major solar flares even when they're out of sight. Keep your eye on the upper right there. That most recent M-class flare did indeed come from that region setting. So Here's just 94 angstroms. And this is a common thing, folks. Sunspots like to make a big entrance and a big exit by producing large flares. It's just the way it works. And it might tell us something about the physics that a lot of people are not yet aware of. So that could be helpful. And let's move right along here and talk about the sky overhead. Yes, so that's what's going on over Lehigh Valley, Pennsylvania. If you want to make your own sky chart, try skyontelescope.org. We show it daily because we encourage people to look up. We got the moon just setting over there around the eastern ecliptic. Quick reminder, if you're up after dusk, viewing the night sky, you've got a great view of Mars, Venus, and that bright star right near it is the constellation Leo's Regulus. So, but Mars and Venus very close together on the ecliptic in the dusk sky. Here's your solar system forecast. That is where things are today. And let's give you heavenly bodies a forecast of those. There's where things will be in a week on the 13th of July. And let's move to coronal mass ejections. So those are kind of important. Again, there is one headed this way, so that's pretty exciting. And we're always delighted to to show those. Just a moment. There we are. There are 102 frames from yesterday. And it was a slow day for CMEs yesterday. Not a lot of stuff going on there at all. It was a quiet 24 hours on July 5th. Let's check today to date. Here are an additional 30 frames from today, and it is still all quiet on the earthly front. So here's Soho, Lasco, C2, NC3 together. Barely any activity there, which statistically places coronal mass ejection likelihood at nearly 100%. Expect some CMEs coming because, well, it's just very unlikely that they'll remain, that all those plasma filaments will remain anchored to the solar disk. Here, let's show stereo A also, just for completeness, because sometimes there's missing data, so we just show stereo A just so people don't think there's any hidden data and this sort of thing. You can see Mercury moving off stereo A's frame there, still visible on the Soho Lasco C3 on your right. Keep in mind stereo A is showing some old data here. This is still July 5th. Those are not synced. And let's move to our custom CME videos. These are going to be pretty uneventful today. That's 24 hours in composite. Here's a little closer view. SDO 193 angstroms along with both Soho coronagraphs. Here's an even closer view. And again, there is a serious filament fest going on here. We're going to show you some fresh imagery of that. You can see a crown prominence up there at the northern hemisphere. At the northern polar region, I should say. And let's take a look at filaments. So here's the ground-based hydrogen alpha telescope at El Teide, Spain. And a lot of dark absorption features down here. Here's the Alex Lifeson filament. Here is the Bella Fleck filament. And we've got another one up here. Another huge one right here. Another filament or two up here. One here, this crown prominence. So plenty of filaments could get names today. If you like, follow the hashtag over on Twitter. The hashtag name that filament. I mean, almost nobody sees the tweets. So, but I guess if you specifically follow us and specifically like look at our profile, you'll see the tweets. I don't know. It's completely broken junkware, just like all of the, major social media. In fact, the whole thing is a monopolized scam. So, if you've unplugged entirely from social media, here at the Smash News Network, Least Busted Name in News, we don't frankly blame you because it is truly pathetic and nonsensical, gross garbage. But we do encourage you to follow us anyway, because you'll see information you won't see anyplace else. And Twitter keeps encouraging us to follow Elon Musk, which I refuse to do because I find his tweets distasteful, boring, and childish. Also, his memes suck. I don't think he makes them himself, but he still shares the most idiotic memes on the entire internet. Reminiscent of an 8-year-old. Not funny, not cool, not interesting, just idiotic. Here's the past 24 hours from SDO 304 angstroms, and you're going to see huge filaments. So we've got some splentacular close-ups, as again you may have come to expect from the channel. So here is that northwestern limb. You can see both the crown prominences up there. There's actually 2 crown prominences. And of course that massive setting sunspot. Yowzers, that is some pretty sweet imagery indeed. And what's that? You want more? You want us to be even closer than that? All right, here you go. Here's the ultra close-up of that setting sunspot group. It did produce an X-class flare, and there still is an outside chance to see a large flare from that, but that likelihood is quickly waning. Also, just a quick reminder, the likelihood of additional coronal mass ejections here is nearly 100%. There are huge plasma filaments all over the solar disk. Their likelihood of staying attached is kind of low. There's the equatorial zoom in the 304 angstroms wavelength. Ionized helium is just a spectacular wavelength through which to view the closest star from the Solar Dynamics Observatory there. Some people's favorite telescope is the Hubble. Some people's telescope of choice is the James Webb. My favorite telescope is the SDO. And we are almost to our bonus feature segment. So since those are 24-hour videos, let's break that down and show some 2.5-hour videos. What do you say? This is a dictatorship, by the way, so you get no say in the matter. We just show what we want. These videos are a manifestation of what I wanted to see when it came to space weather stuff, so that's why we're showing this stuff. We saw a niche which nobody was filling, and so here we are. So that's the past couple of hours, and let's do our bonus feature segment, starting with satellite charging hazards. So we've got some surface charging here at the moment in the Eastern Atlantic. That's low energy electrons on the outside of spacecraft. It could cause some minor communications breakdowns. You can see some of those are significant surface charging hazards. That'll be moving to the Central Pacific as time goes on. GOES electron flux here cratered as we forecasted yesterday. So the electron flux has dipped, a thing you typically do see with coronal mass ejection impacts as well as coronal hole high-speed streams. This is the coronal hole high-speed stream. Expect that coronal mass ejection impact to come tomorrow, sometime around midday or later. There's the one-year graph to put it in context. You'll see that dip today if you follow that later on solon.info. And there's the forecast. You're going to see today's observation will be somewhere down here. So the green boxes are the forecast. The yellow diamonds are the observation. And we'll also show the F-flare of the ionosphere in vibrational frequency, the point at which that electron flux is measured. The F-flare, the bridge between Earth and space at about 300 kilometers of altitude. There it is in vibrational frequency. It's courtesy of the Australian Government Bureau of Meteorology. And no major things going on in the ionosphere here. This is all pretty run-of-the-mill, folks. We show it daily on the channel anyway, as this provides a full day of the ionosphere's vibrational frequency, because you never know when poring over old data could turn you on to something very important, like the Terminator event that Scott McIntosh discovered by looking at old solar data. Anyway, we're seeing quite a bit of high-frequency anomaly happening here. No big deal. It's pretty unremarkable here, in my opinion, in the ionosphere. Again, it's a weak coronal hole high-speed stream impact, not producing a lot of geomagnetic effects. There's the latest image. That's 1245 universal time ionogram and the 1245 universal time anomalygram. That's anomaly in megahertz from a 30-day median. Total electron content is literally a count of the electrons to about 12,500 miles of altitude. The altitude of your GPS satellite. Feel free to pause the video in this frame if you're not familiar with those distances. Here is the total electron content forecast. And we do see some electrons quite out of place here. So some significant nighttime anomalies, but especially southern hemisphere anomalies. So some high electron contents down there in the southern Indian Ocean, the Southern Ocean, around Antarctica. We'll let it play through one more full run just so you see all those anomalies there. Anomalies south of Australia there. Some big GPS errors there occurring in perhaps unexpected locations. A total electron content forecast. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. We'll also show the total electron content anomaly from the 10-day average over the U.S. and, North America in general. And we are seeing some signals here, so check it out. There are some signals over the New Madrid zone. There are some signals there over Yellowstone and the West Coast. So you're going to see this signal just kind of slide past. It doesn't look like a super powerful Earth-originated signal. But there you can see some high electron contents, at least anomalous from the 10-day average, showing up over the U.S. We'll let it play through one more time, and then we'll show the latest solar intensitygram and magnetogram. So there's your refresh. There's your other refresh. This sunspot looks like it's only alpha class so far. In fact, both of these sunspots are alpha class at the moment. I only see one polarity umbra. Those are both south pole oriented sunspots. And as a result, they're kind of unlikely to produce major flares. There's a new group forming up in the north. Check it out. That is a sunspot group, and that is a beta class sunspot group. I can already see that there are south pole umbrae forming there. So there's another group that's got some promise to produce some activity. At the moment, the most likely places to see large flares are, well, there still is some fleeting chance of seeing one here, but also here, and up here, and possibly soon, this group right here. So that's the situation for the likelihood of solar flares. And let's move to our meteorology segment. Now, I discovered like 20 years ago that forecasting the weather is way too easy, which is part of the reason why I took on the challenge of space weather. I wasn't expecting to accidentally stumble upon the mechanism that underlies the solar sunspot cycles, but I did. Because in science, what happens is you ask questions about nature. You typically end up with no answers to those questions, and instead more questions. And sometimes you end up with answers to questions not asked, which is what's happened here. If you want to learn more about that, become a member of the SMASH team. More on that later in the video. We're looking at the world's lowest pressure here at the moment, and it takes place in the southern Atlantic Ocean, near the Southern Ocean. It's about 965 hectopascals, and it's pretty quiet seas here at the moment. So it's calm. The conditions are calm. There are no disastrous high seas to report at the moment. It's pretty chill. All of those major low pressure zones are around the continent of Antarctica. It looks like a pretty good day for Viking raids. So anyway, continuing on here, let's show the wind scenario. These are the surface winds of the eastern planet. We'll also show the jet streams. The jet streams of the central world. Depicted here, and here are the surface winds of this third of the planet. And here are the Americas surface winds and the jet streams. So that's what's going on. And here's what's going on in terms of the satellite map. Great satellite map there from windy.com. Let me just press refresh so that gets animated, because that is a totally sweet satellite map. That is the past 2 hours visible satellite. Here's clouds and fog over the Americas as we zoom in closer and closer to the U.S. Shout out to our viewers from all around the planet who watch the content. Thanks again for tuning in, and congratulations on realizing the channel exists. That's clouds and fog over the U.S. and South America. Check it out. It's station identification. You've reached the Smash News Network, least busted name in news. Whew. We got some heat advisories on the weather.gov map. Weather.gov is where to get your weather warnings. If your location is lit up, just click your location on weather.gov. Those are too many counties for us to cover. Some air quality alerts and some heat advisories. So, since we've got heat advisories, check it out. There is your 72-hour GFS temperature anomaly forecast in degrees Celsius. Got some very hot temperatures coming for the New England states especially. And also some cold temperatures showing up in the north-central U.S., some hot temperatures in the Pacific Northwest, and some cold temperatures along California's coast, the entire left coast there. Also Texas seeing some very cold weather and some large variations. 72-hour GFS pressure temperature forecast in degrees Celsius will also show the 72-hour GFS pressure and precipitation forecast depicted here. So that's what's going on. And here's your lightning mapper. It's the last about 10 hours of lightning. And we do have some thunderstorms crossing Oklahoma here as we create the video. That's a real-time lightning map. Keep in mind this video was not streamed. It was recorded, so we're only going to briefly show that. Some lightning there east of Oklahoma City at the moment. And let's close this thing out so that we can get it onto your screen as quickly as possible. Lightningmaps.org is where you should go next time you hear thunder, perhaps. Today's featured product, by the way, is, well, it's being worn by me. It's the Fauci Face of Evil product. Yes, because accountability always comes, folks. It's inescapable. The universe does not forgive nor forget. I've got my foot on the face. I've got my foot on the face of Fauci right now because today's featured product is the Fauci Face of Evil bath mat. Yeah, if you want to come out of the shower every day and put your clean feet on the dirtiest face perhaps in the world, Fauci along with Neil Ferguson. A great demonstration of how accountability has not come, but it will. Ho, 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 it will. You better believe it will. Fauci, Face of Evil, fraudster. Pick up your products from the Redbubble shop. You can find links below the video as well as on the homepage at the Smash-O merch link, so check that out. Lots of other products, over 30 other designs available from the Smash Team merch shop. SmashOmash.com is the homepage, the official homepage of the Smash News Network. Please bust the name of news, and welcome to the DR Renaissance. Go follow us on other social media, press share, subscribe, like, etc. We built this massive web ring for people like you. We've got a forum. We've even got email alerts for Smash Team members. That's entirely free. Most of the major alerts go out to even bronze level, which will cost you exactly nothing, which is the exact same amount that we've paid big tech to boost our views and friends and likes and all that kind of stuff. Also, we are free speech purists on the channel, which means we will not delete your comments, we will not block you, mute you, ban you, anything like that. We encourage all legal speech, so don't make a fool of yourself, because we will not delete your comments no matter how idiotic they are. That said, if you're not getting notifications from YouTube, sign up for email alerts. We put out email alerts for videos just like this one. All we can do is create the solutions, folks. If you choose not to use the solutions, then that's on you. Anyway, we're closing things out here with the U.S. Doppler radar map, clouds and fog, and water vapor. So there's U.S. Doppler radar, We'll briefly zoom out and show the full 50-state view as Alaska's getting a little bit of precipitation there. Some significant rain there headed toward Anchorage. And here is the U.S. Doppler radar for the lower 48. Some rain around the Gulf states. Moving into Arkansas and Missouri. Toward Mississippi, up the East Coast, and west of Toronto. Here's clouds and fog depicted by the 3.9 micrometer infrared radiation map. And here's the other NASA GOES interactive weather satellite depicting water vapor. We've got a pocket of moisture there in the center of the country, all surrounded by blocking high-pressure features. All that dry, massive air is constraining that moisture and creating huge pressure gradients, which is creating precipitation as water droplets are unable, as water is unable to remain vapor and becomes droplets, aka precipitation. It's relative humidity of 100%, otherwise known as the dew point. There's a U.S. Doppler radar map once again. There is your clouds and fog map. And there is your water vapor map. That should clear things up. And remember, folks, it's pretty easy to forecast the weather if you just understand atmospheric physics, so that's what we are. We are empowering our viewers to be able to do your own forecasting, whether it's in space or on Earth. And since space has got me so spooked, oh my God, the galaxy is going to kill us, folks. I'm so spooked. We do industry research. We do market research about these videos, and we discovered that the galaxy is very, very dangerous. Pardon the sarcasm. I'm going back to the bunker because I've been spooked. So while I'm gone, may that solar wind be at your back. I'm going back to the bunker again. Whoa.